Good morning, good afternoon, good evening again, and welcome to our webinar on cost-effective migration of your on-premises data warehouse to Amazon Redshift. During this webinar, we'll give you a good idea of how to migrate your data warehouse. Our presenters are going to be Nitin Tyagi, our Vice President of Enterprise Solutions at Cambridge Technology, and Ankit Artwal, the Chief Technology Officer at the Lead Group. And we'll give you a little bit of an overview here, excuse me, about about Cambridge Technology. We were formed in 1999. We're a global IT consulting services company, about 450 employees globally distributed, the US, Germany, and India. We have a bunch of notable partners, everybody on the cloud platform, Amazon, Google Cloud Platform, Azure, and Oracle Cloud. And we'll have some partners which we'll talk about a little bit further on. Certifications we carry right now are CMMI Level 5, ISO 27001, ISO 9001, and one we just picked up was ISO 20001. We're an Amazon APN Advanced Tier partner, and we have been engaged with Amazon since 2009. Our services, in summary, cover everything from application development, big data and analytics, data warehouses, data lakes, cloud strategy, migration, enterprise data warehouses, descriptive and predictive analytics, cloud services, again, managed services. We're an Amazon managed services provider, and we provide just about everything on the data and analytics side. We also hold competencies in Amazon. Among those is big data and analytics. We're one of 53 partners, consulting partners, who hold that competency out of an ecosystem of over 10,000 partners. We're happy to be here today, and we're excited about providing this webinar to you today. It should run about 20 to 30 minutes. Some quick housekeeping. If you look in the go to webinar control panel, down near the bottom, one up from the chat, there's a box to type in questions if you have something. When we're done with the presentation, we will provide you with answers to those questions. The agenda quickly is an overview of AWS services, database migration services, data migration services offering. Ankit can provide the Lead Group's case study, and then we'll do the Q&A. Again, thank you for attending. We hope you enjoy it and you learn everything that you hope to learn while at this webinar. I'll turn it over to Nitin, and Nitin and Ankit will take it from here.
Thank you, Peter. So as we look at Amazon Redshift in specific, we wanted to begin with an overview of Amazon services, in specific Redshift. And as enterprises are looking at implementing data warehouses or looking at migrating their existing on-premise data warehouses to the Amazon cloud, Redshift is a data warehouse of choice. Be it on-premise, be it existing legacy data warehouses, anybody looking at from KPI considerations of security, flexibility, total cost of ownership, Redshift is a choice that we've essentially encountered with many of our enterprise customers. We'll look at some of these KPIs in more detail later today during the presentation. But in short, what Redshift is a fast, fully managed data warehouse, which makes it simple and cost-effective for all your data stored in standard SQL servers and using your existing set of BI tools as they may exist. Just to give you all an overview of the AWS Analytics portfolio, AWS offers a whole ecosystem of data storage tools and resources to complement its cloud platform. Redshift is natively integrated with the analytical platform that AWS provides. For instance, AWS Glue is the service which provides extraction, transformation, and loading an ETL tool into Redshift. Amazon Kinesis Data Firehose is the easiest way for you to capture, transform, load streaming data in case you have streaming use cases for Redshift. Or you could use QuickSights for data visualization and reporting. And last but not the least is Amazon provides you with data migration services for loading bulk of data sets from various sources. In today's webinar, we essentially will get into specifics of Redshift architecture. But I just wanted to highlight it from my infrastructure team for the attendees who come from an infrastructure background, how Redshift differentiated. It has a hybrid architecture. When I say hybrid, it has a shared storage, which provides you the ability to scale to unlimited concurrency, while the Redshift instance has on-instance storage as well, which provides low latency access to the data. So the unique combination of shared storage and on-instance storage makes it a best in class in terms of performance. We'll delve a little more into the actual node architecture of Redshift, where it has a leader node and a bunch of compute nodes. A classic use case, a leader node receives the queries from the client applications. It parses the queries and develops an execution plan. This execution plan is given to the compute nodes, which execute in a parallel execution and returns the results onto the leader node. And what has happened over the years is there's a lot of machine learning and result caching, which has been introduced into the Redshift environment, which makes the performance of the entire Redshift platform highly scalable for any kind of data loads. I'm essentially speaking of petabyte scales of data loads in this case. The other aspects of Redshift, which is very interesting and different, is Redshift Spectrum. But before we get into Spectrum, I just wanted to introduce you to AWS Data Lake. For many of you who are not familiar with data lakes is a new and increasing popular way of storing and analyzing data sets, because it allows companies to manage multiple data types from very different sources and store this data, both structured and unstructured, in a centralized repository. And the beauty is when companies implement data lakes, it's obviously cheaper, but Redshift gives a feature called Redshift Spectrum, which enables you to run queries, again, exabytes of unstructured data, which is stored in S3 without loading or any kind of ETL perform. So organizations which have a data warehouse like Redshift and data lake environments, Redshift has an integration in the form of Spectrum, which works with data stored in S3. I should also mention that Redshift is the only data warehouse that extend your queries to Amazon S3 data lake without data loading inward. What does that mean in layman terms? You can query open file formats, maybe a CSV file or a Parquet file or a JSON format file stored in S3 directly. It gives you an ability or the flexibility, I should say, to store high structured, frequently accessed data sets on Redshift's local disk, keeping exabyte of structured and unstructured data sets in S3. And it provides you a seamless capability where you can query both local and data sets to run independent data sets. So that's the combination of Redshift and the data lake with Spectrum that you get holistically. Now, this was the overview of Redshift. We will essentially get into the basics of, as you take the first step of implementing a data warehouse in the cloud, be it starting from scratch or migrating your existing enterprise data warehouses to Amazon Redshift. The next few slides will go into specifics of ways that you could first move your data sets, and then the various tools that Amazon provides to enable this process. First things first is, how do you take your data sets on-premise or data centers or any other location onto the Amazon S3. Amazon provides you a bunch of services, including Direct Connect or VPN connection. You essentially can have a dedicated VPN link from your offices or your data centers or to Amazon, where you can securely transfer your data. It also provides you multi-part S3 data upload. So you essentially can split your files into multiple components and transfer them seamlessly onto the cloud. And in case you're a large enterprise with petabyte scales of data, Amazon provides you Snowball, which essentially can load data, huge data sets, 10 plus petabyte of data sets onto S3. In addition, I just want to introduce you to Amazon Data Pipeline. Amazon Data Pipeline is a web service that helps you reliably process and move data between various AWS compute and storage services, as well as on-premise data sets. So what a data pipeline does is it essentially helps you move data from some of the services, be it RDS, be it an EC2 instance or S3, and also work with on-premise systems to extract the data and move it either to Redshift or any other AWS services. So uploading files to S3. So this is although a very simple step, but there could be many questions that you may have of how you move your data. Your data could be as small as a couple of 100 gigs or terabytes or petabytes of data. You have two choices. You can typically compress your data sets and move them to AWS. You can ship in a hard disk. You can create a hard disk, ship it, encrypt the hard disk, and ship it to AWS. You can move it over the internet. So there are ways that you essentially can either compress or split the files into multiple parts and upload it to S3. During this process, one other aspect that needs to be taken into consideration is the encryption. Amazon provides you ability where you could encrypt both at the client side and the server end to upload the data so that your data is secure during this transfer process. Usually, you essentially can have your own encryption algorithms implemented too. Now, once you get your data into S3, how do you essentially do the migration? How do you take your source data set and move them to Amazon Redshift? Amazon provides you with two services. One is a schema conversion tool and database migration services. We're going to go a deep dive into all these aspects in the next few slides. But at a very high level, it's a four-step process. The first is the schema conversion tool. The schema conversion tool helps you map data types, choose a compression, encoding, the sorting keys, and aspects that you can apply to your DDL. The second step is converting your SQL code, be it your ETL transcripts, your reports, or queries. You essentially convert them these into a format. And usually, depending on the version of the legacy data relational data structures that you have, there could be data type mismatches, which will need to be assessed manually. That at times there'll be manual intervention which is needed. And last but not the least, once you have mapped your schema, you've done your data transformations, what you do is use the data migration service to bulk upload the data. You can either bulk upload or capture updates based on the transformations. So if you're running a warehouse, be it Microsoft SQL Server, be it Oracle database or a MySQL relational database, Netezza, Greenplum, Vertica, any of these enterprises data warehouse or relational database, and you essentially are looking or considering at migrating them to Amazon Redshift, Amazon provides you a tool called Amazon Schema Conversion. Amazon Schema Conversion allows you to run assessments on your existing database or cluster, and these assessments help you to determine the compatibility of your schema from a Redshift perspective. Any PL SQL changes which are needed. It also gives you a suggestion of how many objects can be transferred into Redshift. If there are any manual interventions which are needed, it also gives you an estimate of what kind of effort would be needed to make any of those manual changes. So it holistically gives you an assessment report, which you would have a very decent. This is a tool that you should be able to access from the AWS console. The migration assessment report gives you a very good sense, both in terms of timeline, the number of objects which can be migrated seamlessly, and anything that needs manual intervention or data type changes. Now, that was the Amazon Schema Conversion tool. The second, but not more element was the data migration services. AWS data migration services essentially has a couple of features that I wanted to highlight. The first key element is, as we're using DMS, the source systems remains fully operational. So you don't really have to shut down your systems or wait for nighttime schedules to essentially initiate the DMS services. These are running with minimal impact to your operational data sources. DMS also supports migration of data to and from most widely commercial and open source databases. So it supports both heterogeneous, be it Oracle to Oracle database migrations into AWS, or homogeneous migrations. You essentially are moving from Microsoft SQL Server to Redshift or MySQL to Redshift. It essentially supports both kind of data migrations. In case you have streaming data needs, where you're streaming data coming into Redshift, it also supports that. The key aspect that you also need to take into consideration is it also allows streaming data sets, be it from S3 or be it bulk data load or continuous replication of high availability data sets. So DMS service essentially supports all these aspects, enabling consolidated and easy analysis of data in petabyte scale data warehouses. So the key difference is the scale of data that we essentially saying from what we have looked at traditionally. A typical data migration process has two steps. The first step ideally is you essentially convert your schema, which we saw earlier. You could use an Amazon schema conversion tool, or you could use a native tool to convert your schemas to the destination database. The second aspect is you load your data, you move your data. You can move a bulk upload, which we're going to see in the next slide, or you can do an incremental upload of the data sets. So looking at a little deeper into the data upload process, because this is classic step that most enterprises, once you have converted your schemas, the key step gets into the legacy upload is the data upload process. The first step stage, which we say is we essentially take the full copy of the legacy data. It is replicated to the target system. This is the full load process, that the way that we call it. And it can take considerable amount of time depending on the amount of data and the time it takes to move it. And the key thing about the schema conversion tool extractors is during this process, it might break. So it is self-healing. So in case the process fails, the data extraction process tells by itself. And it is also multi-threaded. So that there are multiple processes running to expedite the full load of the data, as we say. The second stage, which is nothing but the schema, is the deltas. Once you have loaded the full data, then we use the schema extraction tool extractors to do the incremental. So it can go back in date and time and extract the delta and upload it into the data warehouse. So on your screen, you have some data sources on premise that you might be considering, be it Oracle, be it Microsoft SQL to MySQL to SAP to Postgres. You essentially have the DMS supports migration natively to Redshift. Or if you're already on Amazon and looking at implementing Redshift, it supports RDS instances of Oracle to MySQL to Postgres or Aurora databases. Most important, you may be using your proprietary data integration tools, be it Pentaho, be it Cubole, Atinity, Informatica, Metallion, anything. These are supported on Redshift. You essentially will continue to use your existing data integration tools in the cloud. So you have the support. Likewise, on the data visualization, if you're using any kind of visualization tools, you tend to Redshift tend to support most of the data visualization tools, including Tableau, ClickView, and whatnot. With this said, I just want to get over a quick case study of one of the telecom providers who was looking at migrating their data warehouse to the cloud, and their needs were not significantly much. They had a 15 terabyte data warehouses, and their incremental or yearly growth of the data warehouse was 3 to 5 terabytes. They were looking at performing a TCO analysis on this. The needs were very typical of any large enterprises. They were looking at parallel computing. It had to be cost effective. Security considerations were very important to them. Use case, the total cost of implementing a Redshift implementation was coming to 55,000 compared to considering into ETL and the data storage needs for the entire year. The other considerations were Oracle Exadata and SAP HANA, which were in the ballpark of anywhere between 400,000 to 300,000 per annum cost. Now, not just that, when you essentially look at Amazon Redshift, it provides the option where you could purchase reserved instances. Reserved instances let you reduce the price to 40% to 60% based on 1 year or 3 year terms. So it provides you a lot of features where you essentially can significantly reduce your cost based on your cluster needs. The other aspect, which was most important, because most of the times we look at it purely from an infrastructure cost or the software cost, the time it takes to implement or migrate an existing warehouse to AWS. A classic Redshift implementation takes anywhere between 90 days. Within 2 to 3 months, a classic implementation is completed. Whereas if you're doing a similar kind of engagement with Exadata or SAP HANA, it typically is a minimal 4 to 5 months engagement. So just consider the TCO on the cost as well. The other aspect which is very important from a Redshift migration was security. It provides you to create separate subnets. It has an AES 256-bit encryption. So for companies who are looking at compliance, be it SOC 1, SOC 2, SOC 3, or PCI DSS level 1 requirements, Redshift is compatible. So just summarizing on Redshift and the key features, so we spoke about the speed, we talked about the simplicity that you can launch the whole cluster. You could provision the entire cluster with the click of a button from the console. So it has automated provisioning, but key things that I want to highlight is it provides you automated backups. So Redshift automatically backs and periodically backs the data on S3. So you're not essentially worried of manual backup, investing in backup software. Likewise, it is fault tolerant. So in case it detects unhealthy disk, it automatically replicates the data from the failed drives and replaces those nodes, which you'll hardly see in any other system which exists today. The last important thing that I just want to summarize when Redshift, as you essentially are considering it, is looking at industry tools. It essentially integrates with leading industry tools, both in data integration, that is the ETL tools, or data visualization tools. So with that said, I just want to highlight on some of the other aspects of Redshift which are new. So we have been implementing data warehouse on Redshift last 4 or 5 years. And over the last 4 or 5 years, and just in the last year, there have been a lot of enhancements which have come. The first most important is the dense compute nodes. DC2 instance types have been added by Amazon on the Redshift environment. What does that mean? It means that you get 3 times more performance for I/O and 30% better storage utilization than the DC ones, which were the earlier Redshift nodes which were available. More recently, Amazon has implemented something called short query acceleration. Now, what is short query acceleration? Usually when you're running large reports or something, it blocks everything else which is running. What short query acceleration does is the short queries does not get stuck behind long running queries. So it uses machine learning to predict the runtime for the queries, and it automatically routes the short queries in an express route. So that way, it doesn't really impact the short queries and addressing both the larger and shorter needs. The other aspects of this is result set caching. It has built into it. This is one of the features that was introduced last year. Was you can cache your result sets. So if the cache contains the query results, it is returned without processing anything. And if the cache does not have the results, the query gets executed by the nodes. So if you look at what result set caching does, it frees up the Amazon Redshift cluster and increasing the overall performance significantly. Last but not the least, these are for enterprises who are running huge data sets. Amazon has something called Amazon commitments, where 50% faster data commits for busy clusters has been assured. That means 16% faster data ingestion and insertion into these clusters. Last but not the least, we're talking of Spectrum. Spectrum has now been rolled out to 14 additional regions. It supports processing of scalar JSON files and FIAN files, in addition to what it traditionally does, the Parquet text CSV files. It also supports date format now. You'll see Amazon not yet announced, but they soon be able to support nested data support as well in the next few months. With that said, I wanted to pass this on to Ankit Agarwal, who's the Chief Technology Officer of the lead group, to walk through data warehouse implementation. They initiated the journey way back in 2014 and have been on Redshift. Ankit?
All right. Hey, thanks, Nitin. Afternoon, everyone. Like Nitin said, my name's Ankit Agarwal. I'm the CTO at the Lead Group. We are a premier online marketing and lead generation provider based out of Kansas City, and we specialize in the debt settlement and personal loan verticals. So what we basically do is we are in the online marketing space. So we are generating leads for debt settlement and personal loan verticals through email channel, through lead generation websites, through reject solutions, through fail path programs. We also operate a bunch of web properties where people would enter their information. And at the back end of it, I mean, we are running multiple optimization algorithms, multiple systems that are bringing data together from a varied data sources and matching the consumers with the lenders and debt settlement providers, basically, right? What's TLG's USP is our state-of-the-art tracking and reporting systems. What we pride ourselves in is getting the highest payouts to our publishers, leveraging our unique optimization algorithms. Now, that is the state of affairs as of today. But a few years ago, when we started working with CTE, that was not the case. We had several systems, several products, each with their own its own database, its own way of handling data, its own way of handling logs, generating information. So what we found ourselves was in a situation where the data was growing at a tremendous rate, almost 10 gigabytes per day in each system, and we had several of these systems. And reporting was soon becoming a nightmare. We had several reporting analysts whose own sole responsibility was to not actually analyze the data, but go get the data, to put them in a spreadsheet so that somebody else can actually look at it. And it became very clear to us that this is a highly inefficient way of operating business. So pretty soon, we realized that we need a data warehousing solution that would basically bring all of this information, all of this data from 5, 6 different systems into one place and make it a very cohesive, comprehensive solution for us. So that's when we got together with Cambridge Technologies, and they proposed an architecture that would leverage AWS Redshift as our data warehousing solution. So what you see on the screen right now is kind of at a very high level the architecture that was implemented. On the left-hand side of the screen, you have the source databases. I think we've listed 3 or 4, but we were up to 6 different systems. Most of them were in MySQL. And on the right-hand side is the AWS ecosystem, where everything was hosted inside of VPC. And we had separate security groups for running the data warehouse, the Redshift, and everything else was in a different security group. And with everything else, I mean where we were running our Pentaho server, where we were running our staging database, which was again an RDS, MySQL RDS. So the whole pipeline kind of looked like this, right? Every hour, we were moving data from our source databases into a staging database in MySQL, and we were using Pentaho to operate these ETLs. After the ETLs would basically load and cleanse and validate the data, the transformed data would be published to S3. And from S3, we were using the Redshift's copy command to load all of that data into Redshift. And copy command is incredibly fast, and the entire process was basically finishing within seconds. From the moment we would upload the several gigabits of files to S3 in a gzip format, I mean, within seconds, everything would be loaded into Redshift. What we also noticed was, using the different encodings and the compressions methodologies in Redshift, the storage was very efficient. So what would take us several terabytes of space on the MySQL side was actually stored in a much more efficient, much more compact format in the Redshift data warehouse. So earlier, when we didn't have the data warehouse, we were only retaining records for the last 2 years. We had to put in a data retention policy just because the data was getting to a point where running reports on a MySQL database was just becoming almost impossible. Whereas now, once we were moved into the data warehouse, into Redshift, we pretty much have data from day one and have not had a need to purge anything. Right? So, Nitin, if we go to the next slide. Nitin? Thank you. Again, just a quick summary of the benefits that we were able to realize by moving into Redshift. First, our reporting analysts are now actually doing analysis. They no longer have to go into 6, 7 different systems just trying to gather data. The whole process is so streamlined, so seamless at this point. We've actually replaced this manual process, and we are able to now build reports that look at one system, one database of truth, and queries that were taking 10 seconds, few minutes are now actually executing within seconds. Most complex queries were running anywhere close to 10 to 15 minutes, and they're down to less than 20 seconds. Tremendous performance gains achieved by moving into Redshift. Also, one of the tasks that our reporting analysts had to do earlier was to not only go grab the data, but also then somehow validate the data that when they were bringing in data from 6 different sources and putting it together in one, let's say, spreadsheet, the data was correct or not. They no longer have to do that because as part of our ETL process, we've incorporated data validation and data cleansing. So we know whatever has been moved into the data warehouse is accurate. And so the data warehouse has now become our database of truth. So now any reports that we run, we have full confidence, 100% confidence that the numbers that we see are the accurate numbers. Last but not least, now that we have one database of truth, our data science group no longer has to spend a whole lot of time massaging and pre-processing the data to start running their data models on. They now go into one system, one data warehouse, and are able to run several data modeling projects in parallel. And in the last year, we've gone live with one of our machine learning projects, and just in less than a year, we've realized over a 35% improvement on our fail path programs. So again, a tremendous cost benefit from moving into Redshift. And again, I mean, I think you all can see the numbers here, but we are estimating anywhere close to about $500,000 in savings just in the software, hardware, and the maintenance costs, like by being on Redshift, being in AWS for this particular solution. So, I mean, I think that's all what I have for today.
Thanks, Ankit, and thanks, Nitin. That's a really compelling case study. We have a few questions, and we have a little more time left, so we'll try not to bore you, but I think most of these are pointed at you, Ankit. So the first one is, what were some of the performance improvements in your relational database or data warehouse that you experienced?
Absolutely. Like I mentioned, I mean, one of our most complex queries that was running was taking about 15 minutes, 10 to 15 minutes, and that query came down to about under 20 seconds. So I don't know what the order of magnitude is, but it's like several hundred times faster now.
Well, that's pretty amazing. Thanks. Another question is, have you experienced any outage of services on AWS?
Knock on wood, we've been running on Redshift for last 4 years, and we haven't had a single outage on Redshift. Now, there was an incident with S3, so yes, probably you can call there was a minor outage, but Redshift has been rock solid, not even a single outage.
Yeah, it speaks to Amazon's platform as well, the maturity and the security and how reliable it is as a cloud platform. A couple more questions. Does your environment move real-time streaming data into Redshift?
No, we do not move real-time streaming data into Redshift just yet, but what we've done is all that real-time data gets into our real-time databases, sort of our relational databases, and from there on, every half an hour for one system and every hour for another system, we are moving that data into Redshift using our ETLs.
So it's fairly close and it's getting there, but great, thanks. And final question that I have is, have you used the Redshift environment for data science or machine learning? Have you moved down that path yet?
Absolutely. That was our latest project that I was talking about, where we've implemented machine learning algorithm on our exit path solution. And within a year, we have seen a 35% improvement on our I would say earnings. So our data science group has been very happy with the Redshift performance for all their modeling needs at this point.
That's fantastic. Well, that's all the questions that have come up. I want to thank everybody for attending today. Thank Ankit and Nitin for presenting. We hope that you enjoyed the webinar and that you learned something today. If you have any questions, there is some contact information. Please get a hold of us. We'd be happy to help you in any way we can. Again, thank you for attending. You'll get an email with a link to this webinar with a recording so that you can listen again or pass it around your organization. Thanks again. I hope you guys have a great rest of the week and look for more of our webinars. We'll send you invites as we continue to push those through our database of customers and people who are looking to learn more about all the services that are available on Amazon. Thanks again. Have a great day.